Hello everyone, my name is Naina and I'm from the Bodhi Academy. So today we'll be continuing with the chapter that is materials, metals and non-metals. So in our previous video we have seen what are metals, what are non-metals, and we have seen few physical properties of metals and non-metals. So in today's class we're going to deal with chemical properties of metals and non-metals and uses of metals and non-metals. So let's start with the chemical properties of metals and non-metals. So in chemical properties, we'll see reaction of metals and non-metals with oxygen, reaction of metals and non-metals with water, with acid, bases, and few displacement reactions of metals and non-metals. So we'll start with reaction with oxygen. So in your 7th standard, we have seen rusting of iron. So iron is a metal. So you all are familiar with the rusting of iron. So how is the rust formed? So when iron is mixed with oxygen and water, or when iron combines with oxygen and water, or we can simply say with moisture. Moisture has water and oxygen in it. So here it forms so when iron combines with oxygen and water molecules, oxygen from the air, water molecule is the moisture which it absorbs. So it forms iron oxide or ferric oxide. This water is also formed. So here the iron reacts with oxygen to form a ferric oxide. And this ferric oxide is the rust that we get on the iron nail. Similarly, we have burned magnesium ribbon. In your 7th standard, you will have performed this experiment of burning a magnesium ribbon in air. So here also magnesium, it reacts with oxygen. Magnesium, it reacts with oxygen to form magnesium oxide plus water is also, so it forms magnesium oxide. So here also magnesium, it combines with oxygen. This oxygen is from the air. So iron and magnesium, they react with oxygen, right? And both of them are metals. Similarly, have you ever seen a greenish color tint on copper utensils? Copper, when copper vessel is exposed to moist air for long, it acquires a dull green coating. And this green material is a mixture of copper hydroxide and copper carbonate. So here also oxygen plays a role in forming this greenish color deposit or coat on the copper vessels. So as I told you all about the burning of magnesium ribbon, the ash obtained on the burning. So when you burn a magnesium ribbon, you get a white color powder, right? That powder, when dissolved in water and tested for its acidic or basic nature. So that powder, when we check for acidic or basic nature, what we can see is that litmus paper, it turns blue. So when a litmus paper turns blue, what it indicates? It indicates that the material or the substance is basic in nature. So hence all the oxides or the metallic oxides that are formed are basic in nature. Now let us see what happens to non-metallic things. So metallic things, so oxides of metal or metallic oxides, they are basic in nature, as the litmus paper turn bluish in color. Now what happens when we mix non-metallic things with oxygen, or what are the reaction when non-metallic things react with oxygen? So metallic thing, when react with oxygen, it forms a basic substance. So the non-metallic thing such as sulfur and oxygen. Sulfur is a non-metal. When sulfur reacts with oxygen, it forms a sulfur dioxide gas. So this sulfur dioxide gas in water, it forms sulfurous acid. So when sulfur dioxide gas, we mix it or dissolve in water, it forms sulfurous acid, and this itself says it's a acid. So sulfur dioxide plus water gives sulfurous acid. So the sulfurous acid turns blue litmus to red. Generally, oxides of non-metals are basic in nature. So here, oxides of non-metals are acidic in nature. So this is when metals and non-metals reacts with oxygen. So when metals and non-metals reacts with oxygen, what happens? Metallic oxides which are formed. For example, here MgO or Fe2O3, these are metal oxides. So these are basic in nature. Whereas for non-metals, if we combine sulfurous oxide or sulfur dioxide with oxygen or with water, we can take, because water also has oxygen in it. So with water, it forms sulfurous acid or sulfurous acid, and this is acidic in nature. So non-metal oxides are acidic in nature, whereas metal oxides are basic in nature. So these are the things with when non-metals and metals react with oxygen. Now let's see what happens when this reacts with water. So let's see how metals and non-metals reacts with water. So when a metal, if we take sodium, it reacts vigorously with water. When we put a sodium piece into water, it reacts so vigorously, it heats the water. So sodium reacts vigorously with water. Some other metals do not do so. For example, iron, it reacts with water slowly. So the rusting doesn't happen fast. It happens slowly. It takes time to rust the iron nails, right? So different metals react differently with water. Sodium, it reacts fast, but iron, it reacts slow. Non-metals, they usually doesn't react with water. Therefore, they are stored in water. For example, phosphorus. Phosphorus is a non-metal which is very reactive in presence of air. So it reacts very fast in the air. So to prevent it from reacting with air, it is stored in water. So generally non-metals do not react with water, though they may be very reactive in air. Such non-metals are stored in water. For example, phosphorus is a reactive non-metal. It catches fire if exposed to air. To prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. So, what is the reaction? Second one is reaction of metals and non-metals with water. So what happens with water? Metals, few reacts vigorously with water, for example is sodium, and few takes time. For example, iron takes very long time for rusting, so it reacts slowly with water. Whereas non-metals, they doesn't react with water. Hence they are stored in water to prevent from catching fire if they are exposed to air. Few non-metals, they catch fire when they are exposed to air. So those metals are stored in water to prevent them from catching fire. So non-metals, they doesn't react. For example, phosphorus. It is stored in water to prevent catching fire when exposed with air. So phosphorus catches fire when it is exposed to air. To prevent that, it is stored in water, as non-metals doesn't react in water. Let's see reaction with acids. So how metals and non-metals will behave with acids. So there are difference in the way metals and non-metals reacts with acid. So what could the pop sound in some cases? So there is a pop sound. So non-metals generally do not react with acid, but metals react with acid and produces hydrogen gas that burns with a pop sound. So what is that pop sound? That pop sound is of hydrogen gas, which is formed during the reaction between metals and acid. So when metals react with acid, they produce a hydrogen gas that burns with a pop sound. So again, next one is reaction with acid. So metals, they react with acid forming hydrogen gas, which gives a pop sound. Whereas non-metals doesn't react with acid. So metals, they react with acid and they form a hydrogen gas which gives a pop sound, whereas non-metals, they generally doesn't react with acids. So next is reaction with bases. So here metals react with sodium hydroxide to produce hydrogen gas that also again gives a popping sound, whereas non-metals with bases, reaction of non-metal with bases are complex. They react with bases, but it's very complex to understand. So the next one is reaction with bases. So here also metals, they react with base. Again they form hydrogen gas with a pop sound. Whereas non-metals, they react non-metals, they react with base. But in a very complex way. which we will learn in further classes. It's not there for you all here. Now last one is the displacement reaction. So I hope you all recall the displacement reaction that you all have learned in 7th standard. So I'll just quickly refresh it for you all. So what happens in displacement reaction? It's very simple. If I take a reaction where iron reacts with copper sulfate, it gives iron sulfate or ferrous sulfate plus copper. In displacement reaction, what happens? The highly reactive ion replaces the less reactive ion. So this is what a displacement reaction is. So here are few more examples of displacement reaction where copper sulfate reacts with zinc, copper sulfate with iron, zinc sulfate with copper, iron sulfate with copper, zinc sulfate with iron. So here all these sulfates will be replaced by the respective granules or nails or turnings which are given with them. So here what we have seen is that one metal displaces another metal from its compound in aqueous solution. So here iron is a metal, copper is also a metal. So one metal displaces another metal in its aqueous form. So you also mentioned their forms, in what state they are present. Iron in solid state, copper sulfate is in aqueous state, iron sulfate formed is in aqueous state, in this copper again in a solid state. So one metal displaces another metal from its compound in aqueous solution. So for example, if we take two beakers, in one we place zinc granules, in other we take copper sulfate. So when we mix this zinc granules with copper sulfate, a blue color of copper sulfate disappears and a powdery red mass of copper is deposited at the bottom of the beaker. So when we mix zinc into copper sulfate it has a blue color solution. So when we add zinc into it, zinc replaces the copper. So when copper is replaced, the blue color disappears and a red color powdery mass forms in the bottom, which is the copper which is replaced by zinc. So there have been displacement of zinc by copper. So here what happens? Zinc replaces the copper from the copper sulfate. So similarly iron could be displaced by copper. So similarly in another reaction where if we add iron sulfate to copper to iron sulfate, it can also replace iron from the sulfate and form a copper sulfate. So for metals, a more reactive metal can replace a less reactive metal, but a less reactive one cannot replace a more reactive metal. So displacement reaction, it only occurs with metals. It only occurs with metal, where more reactive metals replaces the less reactive one. But less reactive ones cannot replace the more reactive ones. Okay. Now the last part is the uses of metals and non-metals. So metals and non-metals, generally we know where metals and non-metals are used from the examples we have seen. So metals are used in making machineries, automobiles, aeroplanes, trains, satellites, cooking utensils that we use in our kitchen. So similarly we are familiar with the uses of non-metals. Here are some interesting ones. We're sure that you will guess them right. Non-metal is essential for our life, which all living beings inhale during breathing. So what is it? we inhale during our breathing this particular non-metal, that is oxygen. So non-metal used in fertilizers to enhance the growth of plant. Non-metals used in water purification process. Non-metals are used in the purple colored solution which is applied on wounds as an antiseptic. So non-metals are used in crackers as well. You may add some more uses of metals and non-metals from your experience. So non-metals, they are usually used as a fertilizers for water purification processes. They are also used in crackers. Metals, it's a very simple one. We have been using it for our vehicles, automobiles, aeroplanes, trains, satellites, cooking utensils that we use. So these are the uses of metals and non-metals. So in this chapter, what we have seen, what are metals and non-metals. So what are the physical properties of metals and non-metals? So what are the physical properties of metals and non-metals? One is they are malleable. What does malleable means? In our previous class I have discussed it. Malleable means you can beat a metal into a thin sheet. Next is they are ductile. What does ductile means? They can be converted into wires. So only metals are malleable and ductile. Sonorous. Sonorous means they produce loud sounds. So metals produce loud sounds. These are the properties of metals. Whereas non-metals, they are not malleable, they are not ductile, they doesn't produce any sound. Whereas metals are hard, non-metals are soft. Metals are lustrous. Lustrous means they are shiny, and non-metals are dull. One more main point is metals, they are good conductors of heat and electricity. Whereas non-metals, they are poor conductors of heat and electricity. So these are the physical properties. Whereas chemical, we have seen metals and non-metals reacts with oxygen. So when metals and non-metals react with oxygen, they form metallic oxide and oxides of non-metal. So metallic oxides which are formed are basic in nature, whereas non-metal oxides are acidic in nature. Then we have seen their reaction with water. So metals, they reacts vigorously, few reacts vigorously with water. For example, sodium, it reacts very vigorously with water, whereas iron, it reacts very slowly. Non-metals, they doesn't react with water, but non-metals like phosphorus, it reacts or it catches fire when exposed to air. Hence they are stored in water because non-metals doesn't react with water. Reaction with acids. Metals react with acid and they form a hydrogen gas which give a popping sound, whereas non-metal, they doesn't react with acids. As for reaction with bases, similar thing happens with metals. They react with base, they form a hydrogen gas which gives a popping sound, whereas non-metals, they react with base but in a complex way. Last one is the displacement reaction. So ion displacement reaction, what happens? It only happens with metals, where more reactive metals replaces the less reactive ones. And last thing that we have seen are the uses of metals and non-metals. So metals, they are used in machineries, automobiles, aeroplanes, trains, cooking utensils. And non-metals, they are used in fertilizers, for water purification, they are used as antiseptics, and even in the crackers. So thank you for watching my video. Please do like, share and subscribe to our channel.